Welcome to Zvia Weight Loss Medspa. Have you ever finished a meal that really should have been enough? I mean, a real meal, plenty of food, and your body just acted like nothing happened? Or maybe your appetite has changed in ways that just don't make sense, like suddenly you're ravenous after years of feeling in control.
And what makes that so frustrating is that nobody really explains why. You just hear, oh, eat less or have more willpower. But that advice completely misses what's actually happening inside your body. So today, we're going to explore satiety signaling. That's the biological communication system between your gut and your brain that tells you when you're full, and more importantly, what happens when those signals break down.
Okay, so here's what most people don't realize. Your body produces at least five major hormones after every single meal you eat. Each one carries a different message to your brain about whether to keep eating or to stop. And the main highway for those messages is something called the vagus nerve. It runs directly from your gut to your brainstem. So when someone says just stop when you're full, they're assuming the very system that defines full is actually working right. And for a lot of people, especially during hormonal shifts or times of chronic stress, it isn't. The signals are misfiring or the brain has just stopped listening. So let's trace what happens when you eat. Within just minutes of food reaching your small intestine, your body releases a hormone called cholecystokinin, or CCK. It activates the vagus nerve and sends a super fast stop eating signal to your brain. But CCK only lasts for about 1 to 2 minutes. It's designed to stop this meal. It's not designed to prevent the next one. So what is it that keeps you satisfied for hours between meals? That's where GLP-1 and PYY come in. These are released a little later from your lower intestine. GLP-1 literally slows down how fast your stomach empties, so you feel physically full longer. And PYY goes even further. It actually travels to your brain and directly suppresses your hunger neurons. Together, they create that I'm satisfied signal for hours after you eat. And then you've got ghrelin doing the exact opposite. Ghrelin is your hunger hormone, produced when your stomach is empty. But here's what makes it so powerful. It doesn't just make your stomach rumble. It also activates the reward center in your brain. So hunger becomes this real motivational drive. Food becomes genuinely more appealing, more rewarding. That's actually why everything smells so much better when you're starving. So where does all this information end up? How does the brain actually decide? Well, it all happens in the hypothalamus. You've got two opposing groups of neurons that are in a constant competition. One team drives hunger. They're switched on by ghrelin. The other team promotes satiety, and they're activated by hormones like leptin and insulin. The balance between these two determines whether you keep eating or stop. And leptin, which is produced by your fat tissue, is supposed to be the long-term brake on that whole system. But in a condition called leptin resistance, which affects most people who carry excess body fat, the brain can't hear leptin's signal anymore. You're producing plenty of it, but the receptors have become desensitized. So your brain behaves as if you're starving, even when you have high energy stores. It feels uncontrollable because the brake has stopped working. So how does this whole system change over someone's lifetime? Well, in your 30s, the system usually works pretty well. You have predictable hunger and satiety cycles. But then, during perimenopause, declining estrogen reduces the brain's sensitivity to leptin, while at the same time letting ghrelin get louder. This makes your appetite feel really erratic. Sometimes you're intensely hungry, other times it's normal. In fact, a 5-year study followed women through this transition and found something pretty striking. Caloric intake actually decreased by about 250 calories a day. But the psychological desire to eat and subjective hunger increased significantly and stayed that way. That's the biology creating a genuine disconnect between what your body needs and what your brain is telling you to do. And if you add chronic stress to the mix, it just compounds everything. Cortisol stimulates ghrelin, it redirects your appetite toward those high-reward foods, and it promotes the kind of fat that causes inflammation, which just disrupts your satiety signals even more. Okay, so what can someone actually do to support this system? There are 3 things that can make a really measurable difference based on the biology. The first is getting enough protein at every meal. We're talking 25 to 40 grams. And this isn't just some vague idea that protein keeps you full. It's a specific hormonal cascade. The amino acids from the protein directly stimulate your gut to release CCK, GLP-1, and PYY. It is the strongest macronutrient trigger for these satiety hormones. Fiber is fascinating because it creates this delayed satiety effect. When you eat it, it travels down to your colon where it feeds your gut bacteria.
Those bacteria then create compounds that trigger a second wave of GLP-1 and PYY. This is what's known as the second meal effect. It means the fiber you eat at breakfast can literally enhance how full you feel at lunch. And sleep has to be in there. Leptin actually peaks while you're sleeping. That's when your body sends its strongest long-term satiety signal. Even one single night of sleep under 5 hours measurably suppresses leptin and elevates ghrelin. So that intense hunger after a bad night's sleep, it isn't just tiredness. It's a real physical hormonal shift. The most important thing to understand is that appetite is not a character trait. It's the output of a biological system. It has measurable inputs: hormones, stress levels, sleep quality, your life stage. When those inputs change, the output changes. Understanding the science is absolutely the first step. The second is working with a team that gets it at the Zvia level, a team who can look at your specific biology, your hormones, your life stage, and help you work with the system instead of against it. You can visit Zvia.com, that's Zvia.com, or just give us a call at the number on your screen. Schedule your consultation with the Zvia team today. This has been educational information. Your Zvia provider will be the one to determine if this approach is appropriate for your individual needs.